Have you ever been on a plane, maybe thousands of feet in the air, and you look out the window and just think, how is this even possible? It's one of those everyday miracles we just kind of accept. Well, today we're going to pull back the curtain and find out how airplanes really fly.
I mean, really think about it. We're talking about hundreds of tons of metal, packed with people and luggage, just hanging out in the sky. It feels like it should just fall, right? It seems to completely defy gravity. But it's not magic, it's just some seriously cool physics at work.
So, what is the secret? You know, if you're like me, you probably learned a simple little story in school about the wing being curved on top. And look, that's not totally wrong, but it's not the whole story either. In fact, some of the key parts of that explanation are just flat out incorrect.
All right, so first, let's just quickly go over that classic explanation. You know, the one we all got in our science textbooks. This is the story most people think of when they imagine how a plane flies.
The hero of this popular story is always this specific shape. It's called an airfoil, and you can see it right here. It's got that very distinct curve on the top surface, and the bottom is a whole lot flatter. This shape is supposedly what makes everything happen. So here's the logic, and it sounds pretty good on the surface. They call it the longer path or equal transit theory. The idea is that air splits at the front of the wing. Now, because the top is curved, that path is longer, so the air going over the top has to speed up to meet the air from the shorter bottom path at the back of the wing at the exact same time. And thanks to a guy named Bernoulli, we know that faster-moving air creates lower pressure. So you get low pressure on top, higher pressure on the bottom, and voila, lift. It's simple, it's neat, it's easy to understand. It's a really nice story, but it's got some major problems. And when you start to poke at it, the whole thing kind of falls apart. Let's start with this most basic, fundamental assumption. Yeah, that whole idea that the air particles have to meet up at the back at the same time, it's just not true. There's no law of physics that says they have to. And when scientists actually test this in wind tunnels with smoke to see the airflow, the air on top gets to the back way faster. It's not even close. So that whole equal time idea is just a myth. And here's the real nail in the coffin for that old theory. If lift only comes from that special shape, the curved top and the flat bottom, then how in the world do stunt planes fly upside down? Think about it. When the wing is inverted, the longer curved path is on the bottom. According to the old theory, that should be pushing the plane down into the ground. But they fly just fine. This is proof that there is something much, much bigger going on here. So if the old story is wrong, what's actually happening? Well, the truth is that lift isn't from just one single thing. It's more like a recipe, with a few absolutely crucial ingredients all working together. Okay, ingredient number one, and this is probably the most important one, simply pushing air down. This has less to do with the wing shape and everything to do with something called the angle of attack. That's just a fancy term for the angle the wing is tilted at as it cuts through the air. By tilting the wing up just a little, the plane physically shoves a huge amount of air downwards. You've actually felt this. You've totally done this. You stick your hand out of a moving car window, right? If you hold it flat, not much happens. But the moment you tilt your hand up, what happens? The air pushes your hand up. That's Newton's third law in action. For every action, there's an equal and opposite reaction. The action is the wing pushing tons and tons of air down every single second. The reaction is the air pushing the wing and the whole airplane up. This downward deflection of air is a massive, massive source of lift. Now hold on. That pressure difference we talked about, it is real, and it is our second key ingredient. But the old theory just got the cause and effect totally backwards. It's not that the air speeds up and that causes low pressure. It's the other way around. The wing's shape and its angle of attack work together to create a zone of low pressure above the wing first. Think of it like a vacuum or a suction zone. This low pressure area pulls the air over the top of the wing, forcing it to accelerate into that space. So the low pressure is the cause, and the faster air is the effect. And that powerful suction is literally pulling the wing up into the sky. And our final ingredient is a really cool little piece of physics called the Coanda effect. Basically, it just means that fluids, like air, tend to stick to a curved surface. You can see this at home. Hold a spoon under a running tap, and you'll see the water doesn't just splash off, it actually bends and follows the curve of the spoon. The same thing happens with air on a wing. It helps that fast-moving air on top to hug the wing's curve, helping to direct it downwards even more efficiently. Okay, so let's put this all together. If you want to remember how airplanes really fly, you just need to remember these 5 key takeaways. So let's just run through them. Number 1, pushing air down. That's Newton's third law, and it's the biggest player in creating lift. Number 2, creating suction.
That low pressure zone on top of the wing pulls the plane up. Number 3, it's all about balance. For a plane to fly steady, lift has to beat weight, and the engine's thrust has to beat the air resistance, or drag. And number 4, and this is so important, it's a team effort. Real lift comes from both pushing air down and that suction from above working together. And finally, number 5, control is everything. Pilots use all those moving parts on the wings and tail to constantly adjust these forces and tell the plane where to go.
So, the next time you're buckled into your seat and you feel that incredible acceleration down the runway, you'll know what's really happening. It's not just some simple trick with a curved wing. It's this beautiful, complicated dance of physics. This massive, invisible river of air being forced down and a powerful suction pulling from above, all working together to lift you into the clouds. Kind of makes you wonder what other amazing science is hiding in plain sight, doesn't it?